Today I'll talk about reactor mass balance. So here is the problem. 5 reactors linked by pipe are shown in figure 1. The mass flow rate through each pipe is computed as the product of flow Q and concentration C. Each reactor's mass flow into and out must be equal at a steady state. Write mass balance for each reactor and express the equation in matrix form. For example, for the first reactor, a mass balance can be written as input of mass is equal to output of mass. So this is the reactor 1. So input of mass is equal to output of mass. So input is this one, this one, this one, and this is the output. So Q01, C01 is the input, Q31, C31, Q31, C31 is again input. Another stream is coming from C4 reactor, Q41, C41, so that is also input, is equal to output of mass Q12, so that is output from the reactor 1, Q12 into C1. Similarly, write mass balance equation for remaining reactor and then put the value of known parameter. You will get number of equation is equal to number of variable, and now express all the equation in the form in matrix form, like Ax is equal to B. Now, so here 2 in. Okay. Now solve variable x in terms of concentration. Write a MATLAB code to solve for the concentration in each reactor by using Gauss-Seidel method and verify your result with inbuilt function of MATLAB. Okay, now how do you solve this type of problem? So this is the flow sheet. Now we have to solve one by one. Now coming to that reactor 1, C1. So input of mass, you already know, Q01, so Q01 into C01, so that is one input, and then another input, that mass into concentration, mass flow rate into concentration, Q41 or Q31 into C3. Okay, so volumetric flow rate into concentration. So that is the mass. Okay, so volume into some gram by volume, so that is the mass. So that will cancel. So here we are multiplying with volumetric flow rate in concentration. So Q31 into C31. Another that flow stream is coming from that C4, Q41 into C4. Output of mass for the reactor 1, so that is Q12, and the reactor concentration is C1, so Q12 into C1. Now input is of mass is equal to output of mass, so Q01 C01 plus Q31 C3 plus Q41 C4 is equal to Q1 C1. So this is the equation number 1. Next, that C2 reactor. So mass is coming in the reactor Q02 C02. Another mass is coming in from reactor 1, Q12 into C1, so Q12 C1 plus Q02 C01, so that is the input of mass, and then output of mass, so that from reactor C2, so reactor 2, that output stream is Q23 into C2, Q23 into C2 and Q22 into C2, so that is the output of mass. Now write together output of mass is equal to output of mass, so Q12 C1 plus Q02 C01 is equal to Q22 C2 plus Q23 C2, so that is the equation number 2. Now coming to that equation, reactor 3, so one the stream is coming from reactor 2, another is coming from here from outside, so Q23 into C2 is the input of mass plus Q03 plus C03 the input of mass, and out of mass is Q31, so that stream is coming out, so Q31 into C3 and Q34 into again C3, so that is out of mass. So again if we put together, input of mass is equal to out of mass, so Q23 C2 plus Q03 C03 is equal to Q31 C3 plus Q34 C3, so that is equation number 3. Now we have to balance for reactor 4. Input of mass, so this is input, this is input. Okay, so here Q22 into C2 and Q34 into C3, and output of mass is here, so that one stream is coming to the reactor 1, so that Q41 into C4 and then Q44 into C4, Q44 into C44. So that again, if you put together, input of mass is equal to output of mass. So Q22 into C2 plus Q34 C3 is equal to Q41 C4 plus Q44 C4. So that is equation number 4. Now we have 4 equation, and here parameter is C1, C2, C3 and C4. We have to find out. Now if we plug all these parametric value, so we'll get that. So here we are plugging all these values, so all these values known values, and these also concentration, known concentration, so we have to find out this one. So from equation number 1, if we plug all this value, so Q01 is 2, C01 40 plus 2 into C3 plus 2 into C4 is equal to 6 into C1. So if we plug this value, so then we'll get 80 plus 2C3 plus 2C4 is equal to 6C1. If we reorganize, so minus 6C1 plus 0C2 plus 2C3 plus 2C4 is equal to minus 80. So this is the equation, final equation. And similarly for the equation 2, so if we plug this value, so we'll get another, so that is 6C1. So Q12, so if we plug all these values, so known values are given written here. So if we plug all these values, so final equation will get 6C1 minus 8C2 plus 0C3 plus 0C4 is equal to minus 2. So 2 equation we got. Now similarly equation 3 and 4 will get, so that will be if we plug all this value, so 0C1 plus 5C2 minus 8C3 plus 0C4, because why we are putting 0, so it will be easy to write that matrix form. So minus 300. Similarly this is the equation number 3, and then equation number 4, 0C1, if we plug all this value for this equation, we'll get that 0C1, 3C2, 6C3 minus 9C4 is equal to 0. Now we'll get 4 equation and 4 unknown. So if we write in the matrix form Ax equal to B, so it will be like that: minus 6 0 2 2, 6 minus 8 0 0, 0 5 minus 8 0, 0 3 6 minus 9. So this is C1, C2, C3, C4, these are unknown, and B coefficient, B matrix is minus 80, minus 2, 300 and 0. Now we have to solve this matrix and we'll get the answer. So now in your question we have to solve by Gauss-Seidel method. So these are the equation and these are the matrix form. So solve our matrix by Gauss-Seidel method. Now how do we solve by Gauss-Seidel method? So it will be here. First we have to express all this equation is in terms of, so first equation we express in terms of C1, second equation in terms of C2, and third equation in terms of C3, and fourth equation in terms of C4. Now for Gauss-Seidel method, initial guess value is C1 is equal to C2 is equal to C3 is equal to C4 is equal to 0. So we have 4 equation and we have guess value. Now we have to solve that. Now here, so C1, so we are plug C1 for 0, so everything is 0 0 0 0. Now C1 is equal to minus 80 minus 2C3 into minus C4. We plug C3 and C4, so we will get C1 is equal to 13.3. So now second, so for calculating C2, so we have to use the update value of C1, not the old value. So this is update value we have to use. So here C2 is equal to 2 plus 6 C1, so here 2 plus 6 into 13.33. So now again C2 will be 10.25. Remember, for Gauss-Seidel method always use update value. Now for C3, 300 plus C5 C2 by 8, so C3 will be 300 plus 5 into 10.25, again update value by 8, so that will be 14.906. Now C4 again 3C2 plus 6 C3. So again C2 and C3 has update value. So 3 into 10.25 plus 6 into 43.906 will get 32.688. Similar way we can calculate. So we got that C1, C2, C3 and C4. So next iteration C1 will be 33.33. Okay, so now so again C1 is equal to minus 80 minus 2 C3 to C4. So C3 and C4 will be C3, this one C3 and this is C4, right? Using that again we will get C1. Now using that updated C1 value, so we plug that CL value in that equation. So second iteration of the C2, so we get 29.3. Similarly we use update value and we'll get C3 and C4. Now if we do like that, okay, so like that we'll get the result. So now if we do that so on, so one time will come that two consecutive value will be the same. Okay, so then we can stop the iteration. Okay, so now you can see here it is very near, so there should be some stopping criteria. So if that two consecutive value is very near, so we can stop that. So if you do that, so maybe that six iteration you will get that same value or same consecutive value of the two iteration. So then you can stop the calculation. So this is the hand calculation. Now I'll show you in MATLAB. But here I'm not using MATLAB, I am using Octave. Okay, so Octave and MATLAB are same code. So whatever code you write in Octave, so that code you can use MATLAB. So now I will show you in Octave how to do that calculation in Octave platform. Okay, so that I am coming to how to do Gauss-Seidel method in MATLAB. Now these are the equation 1, that is C1 minus 80 minus 2 C3 minus 2 C4 by minus 6, C2 is equal to 2 plus 6 C1 by 8, C3 is equal to 300 plus 5 C2 by 8, and C4 is equal to 3 C2 plus 6 C3 by 9. So these four equation, and Gauss-Seidel method initial guess is C1, C2, C3 and C4 is equal to 0, 0. Now here I wrote this code. Okay, so here if you know how to create the M file, so you can easily create that and you can write everything. So here CLC first you have to put, CLC means clear skin, and then clear all means variable is all clear. Then I put the initial guess, C1 is equal to 0, C2 is equal to 0, C3 is equal to 0, C4 is equal to 0. Now here, so that is I is equal to 1, so that is the iteration number 1. So don't look all this. So this is the formatting for how to write all these variables. Now this is the equation C1, C2, C3, C4, and I am just storing all these value in terms of A, right? So now if you run that calculation, so if you run that, so you will see here in the command window, so iteration 1, that C3, C1 is you are getting, means that MATLAB is giving C1 is 13.33, 10.25 and C3 is 13.91. Now if you do the calculation again, means using that whatever value you are getting in iteration number 1, so for that you have to use that for loop. So for loop I am putting I is equal to maybe 2. Okay, so maybe 2, and then I am putting I am just removing I, and then for loop end is here. Now if you run that program, so you will get 2 iteration, so 13.33, 13.86, so now like that. Now if you run that 15 iteration, so you just put 15 here, I is equal to 1 to 15, and if you run, so that will show you that 15 iteration. Now you can see that two consecutive value are nearly same. So I am arbitrarily giving here 15, but you can put that 100, and there should be some stopping criteria. So for that I am putting here 100, right? Now for the stopping criteria, so first we have to create one A old value, means A old matrix, so that will actually store previous value, and then I am calculating norm of that matrix, so that is A norm. Okay, norm is nothing but a root RMS, means taking RMS value, right? Whatever elements are there, just taking the root square and then under root. Okay, that square under root, and then the C1, C2, C3 will calculate, and then finally that update value again I'm storing C1, C2, C3 like that. Again I'm calculating for updated value. Now here I'm using if statement, so absolute, so that A1 and A, so we are getting that two norm. So if that two norms absolute value less than I is minus 6, means here two consecutive value is less than minus 6, so that loop will not run and it will break, right? And then it will give the that result. Now if I run that, you will see only 18 iteration, means up to 18 iteration it will run and give the value result, and you'll see that two consecutive value is like 52.24, 52.24 and 39.4285, so nearly same. So if you subtract, so you will get that will be less than 1 to the power minus 6. Okay, so by this way you can write small code and you can easily get the Gauss-Seidel method in MATLAB as well as Octave. That's it. Thank you.